My name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the math portion of the GRE. We have been solving math problems out of this book here, the official guide to the GRE, revised general test. If you do not own this book already, purchase one immediately. You're going to need it in order for you to be able to work with me. You have to have the book in front of you so that you can read the problem on your own. The problem that I'm about to solve is the one that you're going to find on page number 122. Page 122, and today is our day number 15. It's a long problem. I'm not going to read it to you verbatim. We'll come to this word in a second. I'm not going to read it to you verbatim, but open the book, turn to page 122 and read the problem to yourself. The gist of the problem is that we have two departments, Department X and Department Y. We are told that the average salary for Department X, we are told, is 25K, the salary. The average for Department Y, we are told, is $35,000. We are also told that Department X has more than twice as many people. We are told that Department X has more than twice as many people. Now, before we get into the nitty-gritty of the fact that the Department X has more than twice as many people, let's first understand what would have happened if we were simply told that Department X has more people than there are in Department Y. Simply more, not twice as many, not more than twice as many. Simply telling me that you have more people in Department Y as opposed to Department X gives us some information about the average. You see, we know that the average of Department X is 25K. The average of Department Y is 35K. The overall average for the entire firm would have been right smack in the middle, would have been the average, would have been the overall average if there were same number of people in both departments. If we had the same number of people in both departments, if we had 100 people in Department X, 100 people in Department Y, and then you go on and tell me that the average for salary in Department X is 25,000, the average salary in Department Y is 35,000, since they have the same weights, 100 people here, 100 people here, they have the same weights, they have the same importance in the calculation. Therefore, the average, overall average, would have been right smack in the middle. The number that falls between 25 and 35 is $30,000. Voila, that's what this would have been the average. But because of the fact that we are told that there are more people in Department X, forget for the time being the fact that we are told that there are more than twice as many people. Simply telling me that there are more people in Department X means that the average is going to be tilted towards this end, towards the left hand. Think of this as a balance. If then the balance, whichever has more weights, the average is going to be tilted towards that. And therefore, the overall average is not going to be this. The overall average is going to fall somewhere in this range. The overall average is going to fall the overall average is going to fall somewhere between, this is between, this part is between, somewhere between 25k and 30k. Therefore, any value that is less than 25, the average, overall average cannot be less than 25,000. Listen carefully what I'm about to say. I'm going to say it very slowly and listen carefully. If you have a group of numbers, the average of that group of number can never be less than the lowest number in the group, and the overall average for the group of numbers can never be more than the highest number. The average has to fall somewhere between the lowest number and the highest number. So we know that the average is not going to be less than $25,000 and the average is not going to be more than $30,000, because in order for the average to be more than $30,000, we would have had to have more people in department Y. We in fact have fewer people in department Y. So any answer choice that falls below $25,000 is wrong. Any answer that falls above $30,000 is wrong. Let's see what we can do here. Because I need the room at this point, I'm going to make a couple of quick comments and then I'm going to erase what I wrote down here. This question obviously deals with the concept of average. And if you're interested in going through a few more interesting problems dealing with the concept of average, you see, here's what's going on. Average sounds like a very simple concept. If you ask most people, do you understand the concept of average? And they will tell you yes. Do you understand the concept of average? And they will say yes. Because they misunderstand the question. They misinterpret the question as, do you know how to calculate average? Knowing how to calculate average and understanding the concept of average are not the two same thing. They are not the same thing, trust me. You have to understand on the gut level what average means. And if you want to get some intuitive understanding of the concept, watch this video. Just type in this tag. Just type in math day 41. Again, math day 31, day 21, day 15 and day 4. Watch those 5 videos where I deal with the concept of average and you will get something out of it. Let's take care of this bottom part here so I can erase it. Verbatim was the word I used. In addition to improving your math skill, if you're interested in improving your vocabulary skill, just type in this tag. Just type in vocab, day, just like math, day, so forth. Vocab, day, and let's see, when did I cover the word verbatim? I know most of you already know the word, but for those of you who do not, or if you want to learn some more words, verbatim, I know I covered it. Well, so much for that. I did not cover it. I have not covered the word in my vocabulary video. Verbatim means word for word. Word for word. So what I told you is that I'm not going to read the question verbatim. I'm not going to read the question to you word for word. I leave it up to you to read it, and I paraphrased it. The word was verbatim, and if you're going to write the word verbatim, make sure that you pay attention to the fact that verbatim has an I in it, not an E. It ends with an T-I-M, not T-E-M. Verbatim. It's pronounced verbatim, not verbatim, but it has an I in it. I'm looking for something to erase with. So that's it. It's out of my system. Let's erase this thing so I have the room. I have to make a note to myself to cover the word verbatim in the vocabulary videos. This is between. So let's look at the answer choices now. Any answer choice that is below 25, any answer has to fall between 25 and 30. So if it's below 25 or above 30 is wrong. Let's look at answer choices. A says 26, B says 28, C says 29. It could fall between 25 and 30. If it can fall between 25 and 30, then A is a possibility, B is a possibility, and C is a possibility so far. D says 30, E says 31, F says 32, and G says 34. You see, let me pause here for a second. I have this uncontrollable urge coming on right now to give you a sermon. So that's what I'm going to do. You see the difference between this so-called revised GRE, the revised one, the new one, as opposed to the old GRE that I'm holding in my hand here, the 10th edition. The difference between the old GRE format and the new GRE format is that the new GRE contains a few new variety of questions. And one of the questions, one new variety that has appeared in the new GRE, which some people find disturbing, are these questions, where back in the old days, the multiple choice questions simply had 5 choices: A, B, C, D, and E. And back in those good old days, out of those 5 answer choices, only one of them was right, and that's it. Your job was to find the right answer, and you're done. Here, they can give you as many answer choices they want: 5, 6, 7, 8, 9, 10 answer choices, and your job is to pick all the answer choices that apply. There are more than one answer choices in some cases, and your job is to find all the right answer choices and click the proper boxes. So if there are 4 right answer choices in a given question, and you only if you only manage to pick only 3 out of those 4, and you miss the 4th one, you won't get credit for the problem at all. There is no partial credit. So the average cannot be above 30, which means D is gone, E is gone, F is gone, G is gone. So far, we have narrowed down the answer choices of these 3. The contest is between these 3. Now I'm going to do the second half of the problem, where the things are going to get nitty-gritty. So pay attention. To start out with, let's pretend. I was going to use the word assume, let's assume, but pretend sounds more fun. Let's pretend that there are, I cannot write, let's pretend that there are, in fact, exactly twice as many people in Department X. And let's find out in that case what would have been the average. What would have been the average? This is the hypothetical statement. Let's pretend. That's hence the word pretend. This is not obviously the reality. We are speaking hypothetically now. So let's pretend that there are exactly twice as many people in Department X and ask ourselves, in that case, what would have been the average? Now, in order for us to do that, we have to make up some numbers. How many people do you want in Department X, and how many people do you want in Department Y? And you want exactly twice as many. So if you're going to tell me, well, let's pretend that there are 5 people in Department X. Oh, sorry, you cannot not have 2.5% in Department Y. If you're going to pretend that there are exactly twice as many people in Department X, so if you're going to pretend that there are 10 people in Department X, then we would have to have 5 people in Y. And we would do 10 times 25 and then 5 times 35 and divide overall by 15. If you're going to pretend there are 4 people in Department X, then you're going to have 2 people in Department Y, and then figure out the overall average. To keep our math simple, to keep our life simple, to save time, let's pretend that there are exactly 2 people in Department X. Let's pretend Department X has two people exactly, and let's pretend, well, this second part is not pretending, this is this, yeah, because we are pretending there are exactly. Let's pretend that Department Y has only 1 person, and ask ourselves what would have been the average in that scenario. Let's find out. There are 2 people in Department X. The average is 25, so it's 2 times 25. That's the weight of 2. Department Y has only 1 person with the average of 35. Let's do it in a different color. Department Y has 1 person with the average of 35,000. So it's 1 times 35. That 1 times 35 was not necessary because I could have just written down 35. And now altogether we have 3 people in the entire firm. In the entire firm, we only have 3 people. 2 people here, 1 person here, 3 people. Voila. This is the overall average for the entire firm if there were 3 people in the firm, 2 in department X, 1 in department Y. Let's find out the average, shall we? 2 times 25 is 50. There is another 25 here. 25 plus 2, there's 75 and an extra 10. That gives us 85. 85 over 3. Let's divide 85 by 3. And for Christ's sakes, do not reach for the calculator. Leave that bloody thing alone that they give you on the screen. It is annoying. Try to do the thing yourself as much as you can. Calculator is only to be used as a last resort. Something as simple as that does not call for calculator. So, how many 3's in 8? There are 2 3's in 8. 2 3's are 6. The remaining 2 goes and joins this guy, becomes 25. Becomes 25 because this 2 here that is remaining is in fact not 2, it's 20. You see, this 2 actually is not 2, it's 20. There are 23's in 80. The remaining 20 goes and joins this guy, becomes 25. So one more time, how many 3's in 8? There are 2 3's in 8. So we put down 2 there. The remaining 2, after you subtract 6 from 8, the remaining 2 goes and joins this guy, becomes 25. How many 3's in 25? 8 3's are 24. 8 3's are 24. And we have a remainder of 1. Remainder of 1. Which is same as 28. Remainder 1 is same as 28 and a third. Which in our, and because this is thousands of dollars, 28 and a third thousands of dollars is same as 28,330. This would have been the average, listen very carefully, this would have been the average, 28,333 would have been the average if we had in fact exactly twice as many people in X. But because we are told that there are more than twice as many people in department X, this is where it gets a little prickly. Because we are told that there are more than twice as many people in department X, therefore the overall average for the entire firm, whatever the hell it is, we know now for a fact that it has to be below 28,333. Because 28,333 would have been the average if there were exactly twice as many people. But we are told that there are more than twice as many people in department X. So they're putting the average down even more. Whatever the current average is, it cannot be more than this. It has to go below that. Which rules out 29,000. Voila, that's it. It can be 26, it can be 28. That's all. I'm going to stop in the video right now because I have the feeling that I have taken inordinate amount of time because I have a tendency of explaining sometimes too much and videos become too long. What I'm going to do is that in the next video, which is going to say day 15, I'm going to continue with the same problem like I did one time before. If I can remember, there you go. If you turn to page number 118, there you will see a problem dealing with the graph question number 3. If you just type in GRE and then p118, you will find this this video on page 118. I taped that one over a 2-day period also because I wanted to explain in detail things that are not required in the problem but just for the learning purposes. What I'm going to do tomorrow, when I say tomorrow in the next video that I'm going to make, is that I'm going to show you exactly how many people we will have to have in department X and in department Y in order for the average to be exactly $26,000 overall average for the entire firm. I'm also going to show you exactly what the breakdown, what the proportion needs to be in department X and in department Y for the overall average to be exactly $28,000, which is not required for the problem. Problem simply says which of the following could be the average. Average could be 26, average could be 28, but it cannot be 29 because 29 is above 28,833. And we know that this would have been the average if we had exactly twice as many people in X as opposed to department Y, but we have more than twice as many people, so it pulls the average down. It's going to be even lower than 28,333. Answer is either A or B. I'm going to continue with this thing as I said in the next video, and we're going to show what the relative weights needs to be in order for the average, in order for the overall average to be 26,000, or in order for the overall average to be 28,000. Alright, I'll see you tomorrow. Bye now. Thanks.